All right, so we're back for section 7.2. 7.2 focuses on similar polygons. All right, so there's been a few words we've talked about throughout math up to this point. One of the first ones was equal, and that basically said two things had the same size. All right, so we had the equal symbol for two things to have the same size. All right, so like that symbol. All right, then we went on a little bit further in math and we talked about congruence. And congruence, we said it had the same shape and size. All right, and we got this symbol, all right, which was like an equal sign with a little squiggle above. All right, so the first one is size. This one is shape and size. And what we're going to move on to today is we're going to move on to similarity. And similarity is just the same shape. All right, now, for something to have the same shape, that means it's going to have the same angle size. Every angle is going to be congruent if it's corresponding. And the sides are going to have to be proportional. So you could have something that's half as big, like you could have a little teeny equilateral triangle, all right, and a really big equilateral triangle, all right, and those two would be similar because they all have 60-degree angles, but the sides are proportional. So if this is a tenth of this one, then each of them will be a tenth of the other one. All right, now what that allows us to do, like in example 1, is it allows us to set up some information just from knowing two things are similar. All right, so this says PQRS is similar to TUWX. Now, we can do all our work just right off of this statement. We can say angle P has to be congruent to angle T, first and first. All right, and then we can go to second and second. Angle Q is congruent to angle U. All right, which the picture really looks like it supports that. Angle R is congruent to angle W. All right, and then last but not least, angle S is congruent to angle X. All right. So those are congruences that we get out of a similarity statement, that those corresponding angles are congruent. Now, the other thing that we get out is we get the fact that the corresponding sides are proportional. All right, and what that means is if I take one side, so let's just say PQ, and I take the corresponding side on the other one, which is TU. So we're looking at this bottom one down here and this bottom one here. If I take the ratio of their length, so PQ over TU, right, PQ over TU, that has to be the same for any of the sides. So if I take the next side, QR, and UW, QR and UW would have to be in that same ratio. All right, same thing if I take the next two, so RS and WX. All right, so as I work my way around, I am basically comparing corresponding sides. All right. And we could do this and work our way around and get each of these sides, that corresponding is always going to be in the same ratio from side to side. And then the last one here, I'm on the notation, I'm going to take first and last. So I've got SP compared to XT. All right, so those ratios have to be consistent for every pair of corresponding sides if the two are similar. All right. Now, we can use this to help us in problems. This one says, determine if a pair of figures is similar. If so, write the similarity statement and the scale factor. So first thing you might notice is it looks like there's only one triangle here. So what I'm going to do is I'm going to take a second, I'm going to actually separate this into two. All right, so I'm going to rewrite this, and I'm going to draw the little triangle QPR. All right, which markings had 3 markings there, 1 there, 1 there. We had 1, 2, and at the bottom was 11. And then I'm also going to draw the big triangle out by itself. So PST. All right, and this one had 2 sections that were tick marked. So I'm going to worry about the angles first. So I've got 1 marking at the top, 3 on the bottom left, 2 on the bottom right. All right, so first thing I notice is that I've got those corresponding angles congruent. So that is a good sign that there's a strong likelihood these are going to be similar. But I do need to also check the proportions on the sides. So this one has 1 tick mark. I'm going to call that an X. This one has 2, so I'm going to call it a Y. All right, when I look at the big triangle had 2 of those sections that were each X long, so it'd be a 2X. And then PT has 2 of the sections we called Y, so we'll call that 2Y. So if I look at ratio of corresponding sides, I've got X over 2X equals Y over 2Y equals 11 over 22. All right, and sure enough, each of these reduces to a half. So we would say the scale factor, all right, from big to small is 1/2. If we did from small to big, then it would be 2 because it would just be going in the other direction. So if I multiply lengths by a half to get from the big one to the small one, then I'd multiply lengths by 2 to get from the small one to the big one. And then our similarity statement here is going to be triangle QPR is similar to triangle SPT. All right, and again, I just set it up so corresponding angles were in the same spot. This last one here says, given the pair of polygons is similar, find the value of x. All right, so first I notice all the angles, corresponding angles are congruent. So when I look at this 12 goes with the 18, and the x plus 1 goes with the 24. And again, I look at angle markings to find the corresponding sides. The x plus 1 is from 1 angle mark to 2 angle marks. The 24 is from 1 angle mark to 2 angle marks as well. So they correspond. The 12 and the 18 are both 1 to 4 angle markings. So I'm going to set up a ratio. 12 to 18 equals x plus 1 to 24. All right, and then we can go about solving that. So if we have a calculator handy, it definitely makes it a lot easier. So we're going to take 12 times 24, and that is 288, equals 18 times x plus 1, using cross multiply from our earlier set of notes. 288 equals 18x plus 18. Subtract the 18 from both sides, 270 equals 18x. And 270 divided by 18 gives us 15. So we get x equals 15. All right, and again, we had to know they were similar to be able to set that up. All right, so I hope that takes you through the second set of notes here. If you have any questions, don't hesitate, bring them to class tomorrow. Thanks, bye.